Okay, so for paper 2 question 7, alright, it's a simple context. Okay, so you have balls numbered from 1 to 3 and balls are drawn one by one with replacement. Okay, with replacement, and you also notice that X is the number of draws. Okay, needed for any ball to be drawn a second time. Okay, so with these two, of course you have 3 balls, right? Okay, so with this info, okay, all we have to be careful of is, okay, don't jump into the question straight away, okay? So we can explore a bit, right? So let's say your first draw is a ball 1, okay, second draw is a ball 1 also, okay? So basically then we would have stopped drawing because we have reached our same ball and been drawn 2 times. Okay, so this is a case of 2 draws. Okay, but if we have B1, B2, and of course B1 again, right? So you notice that I have in fact managed 3 draws. Case of 3 draws. Okay, but to reach 4 draws, it has to be a case of B1, B2, okay, B3, and then okay, B3 has to be different from B1 and B2. The third draw, it should be different from B1 and B2 so that I can get to reach my 4th draw, and the 4th draw can be any of 1, 2 or 3. So I can be B2 again. So this is a case of 4 draws. Okay, so if I go on again, right, we just take another example. Okay, it could, to reach 4 draws, right, a case of 4 draws, it could also be the case where I have a B2, B1, right, ball 2, ball 1, and then this here cannot be B2 anymore, cannot be B1. To reach 4 draws, it has to be ball 3. Okay, so that is different, so that I can continue, and then my last draw can be again anything. This will be a case of 4 draws. Okay, so comparing between these 2 cases of 4 draws, you'll notice that to reach 4 draws, your first 3 draws, there's something that must be true for the first 3 draws, and that is that your first 3 draws must all be different. Okay, so your first 3 draws must be of different balls. Okay, so once you notice this idea, all you have to be careful is to calculate the way to calculate these 3 draws such that they are all different balls. Okay, so the first draw can be, we have 3 balls, any of the 3 balls, right? And for the second draw, okay, it is any ball which is different from the first, right? So I just select 2 balls which are not previously selected. So this will be 2 balls which are previously not selected, and this will be the one last ball which is not previously selected. Okay, this one. which is not previously selected. So then I will have first 3 doors which are different. And finally, I have my last draw, which if you look, could be B1, could be B1, could be B2, and of course it could be B3. So it's the very last draw. Any ball will do. Okay, so from here, then after simplifying, you should be able to get 2/9. But there's one other thing that if you look at your scripts, you will notice that even if you get 2/9, sometimes you might not get the answer mark, simply because I need you to show me very clearly, right? The question is asking us, okay, to show, okay, question is asking us to show, therefore I need every step of your thought process shown in your working. Okay, so this is a very basic requirement of show questions. Okay, so once you have gotten Px equals to 4 equals to 2/9, right? So this would be already in your probability distribution in this table, right? Then all you have to do is figure out the probability for Px equals to 2. Okay, so for probability Px equals to 2, again the same idea. The first draw can be any ball, okay, but the second draw must be the ball that is selected, okay, previously, right? So this can be any ball, okay, but this second one, the second draw must be the ball previously selected, so that it ends on the second draw, ball previously selected. So this must be 1/3, right? So this gives us 1/3 here. Okay, and once you have 2/9, you have 1/3. All you have to do is for Px equals to 3. One very simple way to work around it to find 4/9 is to notice that, okay, Px equals to 5, right? For Px equals to 5, Px equals to 6, and so on and so forth. Okay, you notice that Px equals to 5. Is there any way to have 5 draws? Okay, so if you have B1, B2, B3, and then let's say B2 again, right? Is there any way to reach 5 draws? It would have ended by the at the 4th draw. Okay, so there is no way to reach 5. Px equals to 5, so there's of course no way to reach Px equals to 6, 7, 8, right? So you notice that all the rest of the probabilities here, okay, their probability are all, rest of the events here, their probability are all equals to 0. Okay, so Px equals to 2 only is equals to x could only be 2, x could only be 3, x could only be 4, right? So therefore, okay, so therefore simply you can find Px equals to 3 by taking the complement. So this 4/9, you know that Px equals to 2 plus Px equals to 3 plus Px equals to 4 must be 1, based on what? Based on whatever we have discussed just now. So you know that this is 1/3, this is 2/9, so what is this? Okay, must be 4/9. Okay, so this is one simple way to work it out. But of course, for Px equals to 3, you could also choose to work out step by step. Okay, another way is to work out step by step. You notice that to reach 3 draws, then you notice that it should be B2, B1, and also the last one, for it to end on the 3rd draw, this must be a repeat. Okay, so first draw can be any ball, second draw must be different, right? So 2/3, and finally the last one must be a repeat. So you have already drawn 2 balls, so it must be okay. So the final ball must be a repeat. So we have already drawn 2 balls, so it's 2 out of 3 that we are able to choose from. We can choose from, so it's basically finally 4/9, right? This is the second method. Okay, for 7 part 2, you're asked to show that the expectation EX is 26/9. Okay, so this is generally well done. Almost everyone can do it. Expectation, and then you're asked to find the exact value. So you need the exact value of the variance, right? So exact value of the variance, I need you to take note that it is EX squared minus EX, the whole thing squared. Okay, so just don't forget this square, otherwise it's well done. Okay, and finally for the last part, alright, there are a few common mistakes which I need to highlight. Okay, first thing, right, is that okay, many of you, they are able to recognize that we need to use central limit theorem, okay, since our n is large and it is bigger than 20. Okay, this is not a problem. Okay, what is the problem is that instead of writing the distribution as x bar, you wrote it as x follows normal, which is wrong. Okay, CLT, when you apply CLT, it is for the mean. Okay, the x bar distribution. Okay, so this is the first mistake that I see. Second thing is, of course, okay, approximation. This is an approximation, so I need you to write it down. And finally, in the calculation, okay, GC generally is well done.